for the last chapter of civil engineering orientation, we will be talking about the roles of the civil engineers in sustainable development. So here we will be discussing on how a civil engineer plays his role in sustaining the environment, especially the safety of the people, and how does he meet the needs of the present without compromising the ability of the future generation to meet their own needs. So, civil engineers shall hold paramount the safety, health, and welfare of the public and shall strive to comply with the principles of sustainable development in the performance of their duties. And this is one of the fundamental canons of the Code of Ethics for Civil Engineers. There are two keywords in this canon. First is the safety and the second is the sustainable development. Civil engineers shall address safety and health needs in the design process to prevent or to minimize the work-related hazards and risks associated with the construction, manufacture, use, maintenance, and disposal of facilities, materials, and equipment. So how do civil engineers design safety? In every endeavor, civil engineers shall hold paramount the safety, health, and welfare of the public. The protection of properties and other assets are just secondary. Example, houses and buildings are designed and built by structural and construction engineers against environmental loads due to gravity, earthquakes, wind, temperature, and other external forces to safeguard life or limb, property, and public welfare. Bridges are designed and constructed to resist loads due to traffic and external forces to assure safe and comfortable travel of people and vehicles. So, civil engineers do the design in order to withstand or to prevent unforeseeable circumstances or severe effects from the external forces. Also, civil engineers build resilient infrastructures to promote safety and to ensure sustainable consumption. They are made to make sure that from the foundation or from where the structures rest, it is stable and firm when loads are being added. Also, geotechnical engineers analyze the soil and foundation to make sure that the structures built on them or against them will remain sound and stable. Another one, a safe transportation is planned and managed by a transportation engineer to move people and goods safely without accidents and efficiently from one location to another by land, water, or air. The transportation engineers makes highways, bridges, or any horizontal projects to ensure the safety of every motorcyclist or every drivers that they will reach their point of destination safe and sound. From the design of the width, curves, even on the signages, they make sure that everything will fall into place. Next one, water resources engineers design innovative ways of providing safe, potable drinking water. Infrastructures are designed and constructed to utilize water for irrigation and for producing safe energy. Flood control structures are put in place to protect people and property from harmful effects of flooding. Water resources engineers also take actions to combat climate change and its impact to protect and promote sustainable use of the ecosystem. And how do civil engineers sustain ecological balance? So, ecological sustainability is focused on three goals. First is the protection of human health, deals with human toxicity of building materials, reduction of pollutants, and sick building syndrome, among others. we must use materials that will not compromise human health. For example, is the usage of the asbestos cement from the past years or decades, and nowadays it was being banned because asbestos fibers, they are very microscopic, and if become airborne and inhaled, it may form a fatal disease such as lung cancer. Next is the sick building syndrome. This is a condition in which people in a building suffer from symptoms or illness or become infected with chronic disease from the building in which they work or reside. It may be due to poor or inadequate fresh air intake or inhalation of toxic chemicals coming from, for example, toxic black molds that may occur inside the building. Second one is protection of the ecosystem. It includes waste avoidance, reduction of emissions and pollutants, and proper and efficient land use. The environmental consequences of rapid industrialization have resulted in countless incidents of land, air, and water resources. It includes the contamination with toxic materials and other pollutants, and threatening of human and mainly the ecosystem. The third one is the protection of natural resources, deals with resource efficiency, energy use, and recycling. This talks about the efficient use of our natural resources or the sustainable consumption of what we have, converting the available resources into energy while protecting the environment. It also includes proper waste management and recycling. Ecological sustainability is related to infrastructure development. Civil engineers, being major stakeholders in infrastructure development and the construction industry, must practice activities in construction that contribute to ecological sustainability. Aside from increasing the structure's serviceability, durability, and reliability throughout its entire life, construction must also address the following goals. First is to decrease exhausting or primary raw materials and energy. This is to reduce the total virgin raw material consumption without influencing the function or quality of a product or a process. So what is a virgin raw material? These are the resources extracted from nature in the raw or not being previously processed or consumed, because the time will come that if we continuously use raw materials without preserving or maintaining them, they will soon not be available. Second one is to regulate consumption of renewable resources and to decrease the amount of harmful emissions and wastes. And these goals do not apply in construction but also in various projects and activities of civil engineers. Next is living in hazard-prone regions. Achieving safety and sustainability is a major challenge in regions or countries that are vulnerable to adverse natural hazards like earthquakes, typhoons, floods, volcanic eruptions, drought, and tsunamis. Infrastructures, if vulnerable to these hazards, become inoperable, making them useless. Many buildings and bridges have collapsed in the past due to strong earthquakes and tsunamis. Traffic leads to a standstill when roads and highways become flooded, and water infrastructures become ineffective during water shortages due to drought. That's why there is a planning before construction. We must consider the significant risk of death and damage caused by the prominent hazards just mentioned. For example, if the area is a flood prone or a landslide prone, should you continue to build the establishment there? Or if not, what will be the factors you need to consider in your design? Another example, if the area is near an active fault, what will be the things you need to consider or you need to include in your design? This will be a great help in the planning stage to reduce the fatality and the damage in the near future. And when these disasters occur, the quality of life and the safety of the people are affected. And some examples of the impact of disasters on safety in hazard-prone regions are the harm due to collapsed buildings, the accidents during travel from office to our homes, and the lack of safe drinking water. Disasters also lead to wastage of resources and energy in hazard-prone regions and produces debris, which contributes to environmental deterioration. Sustainability is also at stake in hazard-prone regions. And Figure 1 shows the problem in hazard-prone regions. So the impact of the natural hazards depends on the frequency and intensity of the disaster, and the vulnerability is also being tested, or the vulnerability of an individual, community, or even structures are also being tested. Natural hazards and phenomena are beyond our control, but we can minimize the impacts by providing a certain degree of safety to protect the people, assets, and infrastructures, and to provide sustainability features to protect the human health, resources, and ecosystem. And disasters nowadays are becoming less deadly but more costly. Fewer people are dying in disasters, but the damages to properties are really costly. So, example, we are better now in forecasting disasters, but our building or the other structures aren't designed properly and they aren't ready for these disasters. Therefore, the damages to properties are really costly. And the American Society of Civil Engineers, or the ASCE, made a policy, and under Policy 148 of ASCE, it defines the sustainability as a set of economic, environmental, and social conditions, or also known as the triple bottom line, in which all of society has the capacity and opportunity to maintain and improve its quality of life indefinitely without degrading the quantity, quality, or the availability of economic, environmental, and social resources. The sustainable development is the application of these resources to enhance the safety, welfare, and the quality of life for all of society. By the way, ASCE represents more than 150,000 members of the civil engineering profession in almost 177 countries, and this is known as the oldest and a large governing body for civil engineers. Civil engineers shall be committed to follow the ASCE principles for sustainable development. Their first principle is to do the right project. A proposed project's economic, environmental, and social effects on each of the communities served and affected must be assessed and understood by all stakeholders before there is a decision to proceed with the project. Consider also the non-structural as well as structural solutions to the needs being addressed. So questions like, do we need to build, or do we need this certain project? What will be its uses, or will it be beneficial to the public? Because a civil engineer must have a pre-assessment before proceeding in a certain project. You need to consider many factors as part of your decision-making process, because you will be using, for example, the government project, coming from the taxpayers. So we must consider all possible alternatives before projects and programs are conceived, executed, and operated. The second principle of ASCE is to do the project right. The civil engineer shall actively engage stakeholders and secure public understanding and acceptance of a project's economic, environmental, and social costs and benefits. To move toward conditions of sustainability, engineers must design and deliver projects that address sustainability holistically rather than adding a variety of green features onto a conventional project. We must develop new standards or protocols that are performance-based rather than prescriptive. Those standards must address sustainability and resiliency of infrastructures to ensure the community safety and to recover or to have the ability to recover from the natural and man-made disruptions. ASCE also supports the following steps in achieving a sustainable project. First is to perform life cycle assessment from planning to reuse. Project participants should use rigorous life cycle methodologies that quantify the economic, environmental, and social effects of the project. This aims to quantify impacts that arise from material inputs and outputs, such as energy use or air emissions. Next is to use resources wisely. We must learn to minimize the use of non-renewable resources. Sustainable development shall include progressive reductions in resource for a given level of service and resiliency. The feasibility of, for example, restoration or return of depleted resources shall be evaluated by a civil engineer. And the third one is the plan for resiliency. Sustainability requires planning for the impact of the natural and man-made disasters and changing conditions that can have on economic, environmental, and social resources. Resiliency planning set strategic policies and implement projects that will enable communities to adapt when faced with challenges. It strengthens the capacity of the community or the institution to survive, adapt, and grow no matter what kinds of conditions may be experienced. And the last one is to validate applications of principles. Civil engineers must be guided or they must validate the application of these principles by using metrics and rating tools such as Envision TM rating for sustainable infrastructure. So what is Envision TM rating system? This is a tool which itself is part of a larger system, meaning it was developed to help evaluate the sustainability of civil infrastructures. So this system includes self-assessment checklist, rating tools or tool evaluations and verification programs that helps evaluate an infrastructure. The American Society of Civil Engineers recognizes the leadership role of engineers in sustainable development and the responsibility to provide effective and innovative solutions in addressing the challenges of sustainability. This code of ethics states that engineers shall hold paramount the safety, health, and welfare of the public and shall strive to comply with the principles of sustainable development in the performance of their professional duties. So ASCE works on a global scale to promote public recognition and understanding of the needs and opportunities for sustainable development and contribute to health communities. Also, the environmental, economic, and social development must be seen as an interdependent and complementary concepts where economic competitiveness and ecological sustainability are a complementary aspect of the common goal of improving the quality of life. So civil engineers have a leading role in planning, designing, and building, and of course ensuring a sustainable future by providing the bridge between science and society. In this role, engineers must actively promote and participate in multidisciplinary teams, so not just with the other professions in engineering field but also in the other disciplines like ecologists, economists, and sociologists, and work with the community served and affected to effectively address the issues and challenges of sustainable development. So this ends the Civil Engineering 100 or the Civil Engineering Orientation. Therefore, as a civil engineer in the future, I am looking forward for you to play a major role in sustaining the environment. You will be working with different professionals in different fields, whatever your chosen specialization will be. But I believe that you will adapt whatever you have learned in this subject. So good luck, future civil engineers. This is only the beginning of paving your road towards this profession. So I wish the best for all of you, and I hope that after 5 years or 6 years, or depending on how many years you will take this course, you are still pursuing this profession, whatever odds may come. So God bless future civil engineers. Good luck.